Okay, everybody, this is chapter 11, section 6. This deals with the surface area and volume of a sphere. So that would be a ball. Okay, there are a bunch of definitions here. So I'll pull them up, and then if you want to hit pause, you can read those and write those down. So give yourself a little bit of time on these, okay? Okay, so hopefully you got all those down. Couple things, some are new, some are ones that we've talked about before. The term locus here in the first definition, that's just a series of points that are in a circular shape. So it could be a circle is really a locus of points, and so a sphere would be the same kind of thing. So it's just a fancy word for the series of points that make up a circle or a sphere. Okay, we know that center, we've talked about center a lot in different things. It's just equidistant, so it's the middle of the circle, or in this case, the middle of a sphere. A radius, we've talked about, it goes from the center out to a point on the circle or the sphere. A chord, though, is something new. So if you just go ahead and draw a circle, a chord connects points on a circle. So it could be really anywhere on the circle or in a sphere. It just connects 2 points on the circle or sphere. Okay. A diameter, though, is a little bit more specific type of chord. It's got more rules. It's going to connect points on a circle similar to a chord, but it has to go through the diameter, or it has to, I'm sorry, it has to go through the center. It creates a diameter. Okay, so a diameter is a special chord, kind of like the hypotenuse is a special side in a right triangle. So it's just a different name for something. Okay, so those are your kind of definitions we need to have. We need to find the surface area of a sphere or a ball. So they're going to give you the surface area formula right here. It's 4 times pi times the radius squared. So you need the radius. We're still going to call pi being 3.14. I'm going to do something a little bit different with this formula than I have in the other ones with the pi. I'm going to leave pi in the problem all the way until the end, because sometimes on some tests like your SAT tests and SAT tests, your standardized tests, sometimes they don't want you to multiply pi out. They just leave it like as a variable. So I just want you to get used to kind of seeing it that way. So I'm going to leave it until the very end, say, hey, the answer could be this way, but when you multiply it out, here's how it would look as a number. Okay. All right. So they're giving me the radius of this particular problem. And I'm just going to write the formula up there so we can see it. They give me a radius, so I'm going to go ahead and use that. I'm going to leave pi as pi for now. My radius is 2, and I'm squaring it, okay? So I can go ahead and kind of multiply that out. 2 squared is 4, and 4 times this 4 gives me 16 pi, okay? So your answer really could be represented that way. Like I said, you might see it on certain tests, but we're going to go ahead and multiply that out. So we're going to go 16 times 3.14, and that gets me about 50.24. And if I was going to round it to the nearest tenth, it would be 50.2. Okay, so hopefully a pretty easy one. We give you problems like this where we're giving you the diameter is 8, but I need a radius. Okay, so I really want to cut that in half. So I'm going to get a radius of 4. And now I can go ahead and do this problem again. So if you want to hit pause and do this problem kind of on your own, and then I'll put the solution up for you, okay? Okay, so there's the solution for this one. I could leave the answer as 64 pi. If I multiplied it by 3.14, I'm going to get that. And I can then kind of round that if I really want to, so I can get 201. And remember, we're finding surface area, so I forgot in the last problem to put my units in. So just kind of remember to do that, all right? So that's how to get surface area, pretty easy formula. And I just did a little bit differently, that pi could be used as just a symbol in my answer. I don't have to multiply it out by 3.14, okay? Okay, so this is just another example, another problem to try. Unfortunately, this one is the same as what we just done earlier. So on this one, if you guys could change that 2 inches into 16 inches and go ahead and find the surface area, remember 4 pi r squared, in this case, the radius is 16, okay? You could hit your pause button and do the math, and then I'll put the solution up on the board for you, okay? Okay, so the radius was 16. 16 squared is 256, and 256 times 4 gives me 1,024 pi, so I could leave my answer that way, but multiplying it out and round it up gets me 3,215.4 inches squared, okay? All right, so hopefully that was a pretty good one for you. Got through those pretty well, all right? Okay, we have two definitions here talking about a great circle and a hemisphere. So if you want to hit pause and go ahead and write these down, and I'll go over these a little bit. Okay, if a plane intersects a sphere and it contains the center, so that's pretty important, then this intersection is a great circle. So the dotted lines here are the great circle. So if you want to make an easy reference, a great circle is something like the equator. We assume the equator is like halfway around the world, or halfway, you know, the latitude wise. And then halfway longitude wise, you could think of it either way, but it basically splits the earth equally in half, and that great circle would be like in a radius with the center of the earth. So it's just like an equator, and then it splits it in half. So a hemisphere is half of a circle, okay? A hemisphere is half of a circle or half of a ball, okay? So it's like we have the northern and southern hemispheres here on Earth, okay? So when they talk about example number 2 down here, they got a great circle on a sphere, so the equator on a sphere measures 12 pi. Now I want you to think of this too. This is like the circumference. So if you think of the equator also as being the circumference of the Earth, that's what that is. And they want to get the surface area. Now we got to think this one through. A pretty tough problem to kind of go off that definition and go here. To get the surface area of a sphere was 4 pi r squared. And basically they gave me the circumference. Well, circumference is 2 pi r. Well, for me to get the circumference, or the surface area, all I really need is a radius, right? So if I can understand the relationship here, that circumference is 12 pi, I can go ahead and do this. Sorry, that's a pi symbol. My pi symbols aren't very good today. I can set that problem up, and can I solve this for pi? I mean for r. So yeah, I can, because if I could divide both sides by 2 pi, and I don't even have to change pi to 3.14, that's going to get me, it's going to cancel out over here. That's going to get me a radius of 6. So now I've got the radius of being 6. Can that help me then go get the surface area? Okay, so hopefully that kind of made a little bit of sense. So the surface area is going to be 4 pi, radius is 6 squared, and then 6 squared is 36, and 36 times 4, I forgot to do that. Let me do that over here really fast. 144. I get 144 pi. Okay, sorry, that's a pi symbol. You guys already know my writing's bad. It's getting worse, I guess. Okay, so I get 144 pi, and I can go ahead and multiply that out if I want. I could leave it that way, or I get 452.2, and this was in feet squared. Okay, so that's a pretty good problem. That would be a test type of a question right there. You want to be able to remember how to do that. But taking, being able to take the definitions we just got and making, hey, a great circle really is a circumference of a circle, or circumference of a sphere in this case. I can use that to get me what I want. All right. So they give you another problem here. So hopefully you can find a little bit of room. They tell you that a great circle on the sphere is 20 feet. So really that's the circumference. Okay, so I want to kind of do this, use that to help me get the radius, and then go back and find the surface area of the sphere, because now I've got the radius. Okay, so once you hit pause and do that really quick and see what you get. Okay, so there you go on that one. Over here on the far left, I set the great circle had a. This should have been pi up here. I'm sorry about that. Didn't catch that one. Set it equal to 20 pi. Divided both sides by 2 pi, and then was able to get a radius of 10. Okay. Sorry about that pi symbol being not there. I didn't catch that. All right. And then the surface area, I can take that radius of 10, go ahead and plug that in, and get 400 pi, and then I want to multiply that out by 3.14, and I get out 1,256 feet squared. Okay. All right, so hopefully you did pretty good on that one. Sorry about that. I don't know why that was missing. I didn't catch that earlier. All right. Okay, within this section, we also have the volume of the sphere. So this is what we're trying to find, all that stuff inside. So like, you know, if you went and got a scoop of ice cream, let's just say it came, you know, totally in a ball shape. It's all that ice cream inside that ball, basically, all right? This formula is a little bit different. So I kind of do this. I've done this lots of different ways, but this seems to be the best. I'm going to go 4 pi r to the third and divide it by 3, okay? So it's really important that you use that. We're cubing the radius here, and we're used to r squared, and that's a mistake that we can make. I feel like the way that I've set this formula up this way is much more friendly, I guess, for us to be able to do. So I'm going to kind of do it that way, okay? Okay, so let's go ahead and do this one. We're going to take the radius as being 4. So we're going to go volume 4 pi, radius 4 cubed over 3. Okay, so I'm going to leave pi as pi for a little bit here. 4 cubed is 4 times 4 times 4, which is 64. And then 64 times 4 gives me 256 pi over 3. I could probably leave my answer like that. I think if I divide 256 by 3, I get like 85.3 pi. So you could leave it like that if you wanted to. But if I was going to multiply that out, 256 times pi, so 3.14, and then I divide that by 3, I get approximately 267.9. Okay, the units was meters, so meters cubed, because I'm finding volume. Okay. All right, so that's how you do that. And you know, guys, it's just sticking numbers into a formula and doing some math. And at this point, we know how to multiply and divide and cube and square and whatever. So you just got to know the formula and know what you need. Stick it in there and let's go. Okay. So that's the one kind of basic problem for that one. These two problems that we're going to do now are pretty complex. Just need to read it and think and understand what you need to do. These are problems that you will see a lot. Just being able to take different things and kind of put them together, okay? So we're going to make a steel ball bearings, like what goes in the wheels of like a skateboard wheel, or even like a bicycle wheel needs ball bearings to kind of roll or spin on the axle. So, but to make those, we make those out of a slug that's a cylinder shape. So a slug just a piece of metal, but it's in a cylinder shape. We're going to heat it, and then we're going to press it into a spherical shape. So it's going to have the same volume, okay? They want to know the radius of the ball bearing made from the following slug. So basically what I want to do is I want to get the volume of a cylinder, so I'll call that VC, and it's going to be equal to the volume of a sphere, okay? So if I go back a couple sections here, the volume of a cylinder was the area of the base times the height. The volume of a cylinder was what we just did, 4 pi r cubed over 3, okay? So we need to kind of think that way. I'm going to kind of work that way. So let's do the first thing. Since they gave me a cylinder, let's find the volume of the cylinder. If you remember the area of the base of this cylinder is a circle, so pi r squared. So pi, and I'm gonna do this in number form here, okay? So 3.14. The radius is 1, so 1 squared is going to get me 3.14. Okay? And now I'm going to take that and multiply it by the height, and the height of this cylinder is 2. Okay? So when I multiply all that out, I get the volume of the cylinder is 6.28, and I'm going to leave it like that for right now. Okay? I want to be a little bit more accurate on this one, so I'm going to leave it as 6.28 just for this one. Okay? So I'm going to take that 6.28, and if you go back to what I started with, the volumes are going to be the same because I'm using the same material. It's just I'm going to reshape it, and that's going to equal 4 pi r to the third over 3. Okay. Okay. Now I want to get rid of the fraction here, so I'm going to multiply both sides by 3. And I'm going to get 18.84 over here, and I'm going to get 4 pi r to the third. Okay. So what I'm going to do over here now is I'm going to simplify this 4 pi. I'm going to multiply 4 by 3.14. So I'm going to get 18.84 equals 1, 2, 5, 6 r to the third. Okay. I'm then gonna I'm trying to solve for r. They're asking me what's the radius of this ball bearing now. So I'm going to divide both sides by 12.56. And that gets me r to the third equals approximately 1.5. I did round that. Okay. So at this point, how do you solve for r? Well, if I want to get r all by itself, I'm going to have to take the cube root. I'm taking the cube root because of that exponent 3, or r to the third power. And so remember on your calculators, if you have one kind of like what we have in class, you want to put in the number 3 first, hit the second function button, and then hit the button that's got the x as the root, and put in 1.5. Okay, and we'll round this to the nearest 100th here on this one, and I get 1.14. So that's going to be the radius of our ball bearing doing all that stuff. Okay, so a pretty cool problem. I did it all for you. Hopefully you just kind of followed and were understanding that. Go back and look at this again, just so you get a better idea. And I did do things a little bit differently. I kept it out to the hundredths place, more for accuracy. The more places I go, the more accurate I am. Okay. All right. So what I'd like you to do, this problem is, doing a couple different things together, and trying to be able to figure this one out. I'll just kind of give you a little clue. Okay. You got a tennis ball can. So I'm just going to draw you a tennis ball can. Hey, that looks like a cylinder to me, and it's got 3 tennis balls in it. Okay. And I'm assuming they're all the same size. I'm assuming the tennis balls touch the bottom of the can, touch the top of the can, and touch the sides of the can. Okay. And they give me a radius of the balls. Well, I'm going to assume that's also the radius of the can. And they want to know what's the minimum volume of the sleeve if the tennis balls have a radius of 2. So what I want to do is find the volume of the cylinder and find the volume of the balls, which are spheres. Okay, so it's pretty much like what you just did, using the same things. But I want you to figure out what they really want to know is how much space are the balls taking up, because there's these little air pockets in here. Okay, so the balls are going to be the minimum volume of the sleeve. Okay. All right. So once you're going to, you're finding this volume of the balls, and you're going to get the volume of what's not being taken up by the balls. Okay. So once you hit pause and see if you can give this one a shot, then I'll put the solution up for you. Okay. let's talk about this a little bit. I haven't given you the total answer yet. I want to make sure I explain some stuff to you, okay? Over here on the left, I found the volume of the cylinder, okay? So that was the area of the base times the height, okay? Now, I want to make sure we understand something. The area of the base, we assumed that the radius of the ball is touching the side of the cylinder, okay? And they told me that was 2. So I can use that to assume that the radius of the cylinder is also 2, okay? And then, so that's where I got 2 squared, okay? And I'm using 3.14 as pi right off the bat. But I also had to get the height, okay? Now the radius of the ball is 2 this way also, and it's going to be 2 this way also. So basically the height of each ball is 4. I hope you follow that. So that means each ball has a height of 4. That gives me the cylinder has a height of 12. So that's where I got the 12. I multiplied that all out, and I'm going to leave it in the hundredths place just for accuracy and because I did it in the previous problem, okay? All right, so that's how you got the volume of the cylinder. Now over here, I did the volume of a sphere, okay? To get the volume of one ball, the radius of the ball was 2 again. I cube it and I multiply it to 4 times pi, and I get 100.48. And then I want to divide it by 3. That gives me the volume of one ball, and it came out to like, I forget what it was now. It's like 33 point something or whatever, okay? But that's for one ball, but I've got 3 balls. So what I'm going to do is, if I divide it by 3, I'd have to turn around and multiply it by 3 balls. So what I'm going to do is just take this 100.48. So I hope you follow that. If I divide it by 3, I'm going to have to turn around and multiply it again by 3. So I'm going to forget about doing that because it actually ended up being 3 balls, okay? So the volume of the spheres in the can is 100.48. So what I want to do now is take the volume of the cylinder and the volume of the spheres or the tennis balls and subtract them, okay? And so when I do that, I get that empty volume is about 50.24 inches cubed, okay? So that question shows up in tests, finals. You'll probably see it on an SAT test in some form. They probably would not have you do it as pi, multiplying out by pi. There'll probably be pi in the problem. Okay, so those last 2 are really good problems for you to hopefully get a good understanding. So watch the video again, understand. We had 2 different kind of concepts going together. Okay, thank you.